Listen, most biology students lose completely easy marks on Section 3.1 of the 9700 exam. We're talking specifically about investigating enzyme catalyzed reactions. You know, things like the breakdown of hydrogen peroxide by catalase or starch by amylase. It happens all the time. But after this explainer, you are absolutely not going to be one of them. Today, we're exploring exactly what examiners are actually looking for, and more importantly, where you might be unknowingly leaving precious points right there on the table.
Take a look at this statement. The enzyme worked faster and produced more product. Now, honestly, that feels completely natural to write, right? But it is a major trap. Writing something like this under exam timing pressure is exactly what causes those unexpected confidence shocks when you get your paper back, and it puts your grade boundaries at serious risk.
Okay, let's dive into this. That generic student answer you just saw, it is immediately going to be met with a giant red question mark by the examiner. Ordinary revision completely fails here because, well, memorizing the textbook just doesn't prepare you for specific exam expectations. You need structured reasoning, not just basic facts thrown at the page and hoping something sticks.
And here is your actual grade boundary risk. The major hurdle for most students, the place where the marks really slip away, is evaluating evidence and drawing conclusions. But don't worry, we've got you covered. By the end of this explainer, you're going to have the exact strategy to transform these generic, low-scoring answers into top band responses that perfectly satisfy the assessment framework.
Section 1, Core Concepts and the Open Loop.
Let's look at the underlying theoretical architecture for enzyme reactions. So Cambridge prioritizes analytical depth over superficial breadth. What does that mean for you? It means your answers absolutely must rest on precise definitions and crystal clear causal relationships, like exactly how temperature affects the kinetic energy of amylase molecules hydrolyzing starch. You can't just say it gets hotter so it goes faster. Furthermore, candidates who reference cross-topic connections achieve significantly higher marks. It's like a giant puzzle. You need integration, not isolated facts. Now, in just a moment, I'm going to share an examiner clue sourced directly from the principal examiner reports that will change your approach to these answers completely. But first, you absolutely need the core framework that makes this clue so obvious. If you skip ahead right now, you'll miss the one foundational piece of advice that literally unlocks the top mark band. Section 2, Technical Methodology Framework. To build that framework, we break down complex problems step by step using what we call the deconstruct, solve, evaluate methodology. Let's move to and see how this builds. First, identify given information. Second, break it into logical steps. Third, solve it systematically. Fourth, check for reasonableness. And finally, make justified recommendations. Following this sequence is your ultimate defense against careless errors.
And this ties right into the method mark strategy, which is absolutely crucial here. Examiners award marks for your process and your clear working, not just the final mathematical result. Writing out clear notation and showing that procedural framework is exactly how you earn partial credit, even if your final answer turns out to be slightly off. A really huge part of this process involves data interpretation. You have to be able to extract data from tables, interpret relationships, and calculate relevant statistics. The essential tests you need to know include the t-test for comparing means, chi-squared for categorical data, and correlation tests for variable relationships. I cannot stress this enough. Picking the right test is absolutely critical for Section 3.1.
Section 3, Fixing Flawed Answers.
All right, let's put this into practice. I want you to pause and predict right now. How would you rewrite that flawed answer from the beginning to hit the top mark band? Think back to the concept evidence reasoning framework we just discussed. Where exactly did that student go wrong? And this brilliantly illustrates the difference. Instead of a generic rate increased, a top-end answer is going to say something like, catalase rate increased due to a specific factor supported by extracted data. Do you see how it moves from a vague concept to very specific evidence extracted directly from the stimulus material, followed by clear scientific reasoning? That right there is how you satisfy the examiner.
Section 4, Principal Examiner Warnings. All right, now it's time to close that open loop. Sourced directly from Cambridge Principal Examiner reports, there are 3 massive mistakes that consistently destroy student marks when investigating catalase and amylase. Let's look at them.
Mistake number 1, using the wrong terminology for the specific context. It's a total classic trap. Mistake number 2, candidates simply forgetting to check their units and terminology before finalizing their working. And mistake number 3, which is arguably the most fatal of them all, providing generic answers that are not specific to the context given in the question. So the crucial point is summarized perfectly by this principal examiner alert. Always link every point to the given scenario. Listen, if you write a perfect textbook definition, but you fail to link it to the specific enzyme, the specific substrate, or the specific data provided in the prompt, you will absolutely cap your marks.
Here's a super quick memory hack to boost your attention during revision. Try creating a personalized acronym for the experimental variables and factors affecting catalase and amylase. A great one is TEEPS. That stands for temperature, enzyme concentration, pH, and substrate concentration. Having a mental shortcut like this ensures you never just freeze up when you're evaluating an experimental design. Section 5, the final exam strategy.
Let's bring the whole shebang together into a final, high-stakes, tactical recap. When you actually sit down for the exam, follow this standardized sequence. Step 1, deconstruct the stimulus data. Step 2, select the correct analytical framework and statistical test. Step 3, execute your analysis showing clear notation to secure those sweet method marks. And Step 4, present your final answer using correct context-specific terminology.
Okay, so you now have the ultimate structural framework, but there is a hidden cause of lost marks that we haven't even covered yet. What if your perfect biology, your flawless methodology, and your precise evidence are entirely ruined simply because you misunderstood one single command word in the prompt?
I mean, think about it. Do you know the exact structural difference between describe, explain, calculate, and evaluate? Misreading just one of these command words will immediately cap your mark band, regardless of how good your scientific reasoning actually is. You simply cannot risk losing points after mastering the methodology. Understanding these specific instructions is literally mandatory for your survival in this exam. And that is exactly what we are breaking down in our next explainer, Biology 9700 Command Words That Decide the Mark Band. You really need to jump into that explainer right now to ensure your framework actually gets the marks it deserves.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations.